In this set of slides, we talk about the behavioural perspectives. So the assumptions of traditional finance are not universally observed to hold. Let's look at two aspects: attitudes to risk and bounded rationality. So this shows a complex risk function, meaning that risk evaluation depends in part on the wealth level and circumstances of the decision maker. It's not necessarily true that an individual's utility function has the same curvature consistently, as we showed with traditional finance. There may be levels of wealth, for instance, at which an investor is a risk seeker, and levels of wealth where the investor is risk neutral. Researchers Friedman and Savage found that people must be paid a premium to be induced to take moderate risks. If the investment offers a few extremely large prizes, its attraction is increased far beyond the aggregate value of those prizes. Those with less income prefer either certainty or a risk that offers a small chance of a large gain to a risk that is moderate, and middle income people are more likely to be attracted by small, fair gambles. Similarly, bounded rationality assumes limits to knowledge intake capacity and removes the assumptions of perfect information, fully rational decision-making, and consistent utility maximization, i.e. the assumptions of traditional finance. Bounded rationality shows that individuals satisfice. That means that they select an outcome which offers a sufficient level of satisfaction, but it may not be optimal according to maximizing expected utility. For example, Bob has cash that he wants to earn interest on, have accessible, and protect against loss. He has decided to deposit the funds in an account down the street that is a member institution backed by government guarantee. It will pay 3%. Why is this consistent with bounded rationality but not rationality? The answer is that Bob didn't do the optimal level of research, and he gathered some information but not all available information. And he stopped when he'd arrived at a satisfactory, not necessarily optimal decision, i.e. the bank down the street. So that's what we call bounded rationality. People are bounded by their knowledge and the capacity to gather all information and process that information in a rational way. Now, prospect theory is a behavioral finance alternative to expected utility theory. It describes how individuals evaluate prospects or investment alternatives in this context. There are two phases: the framing-editing phase, where the goal is to simplify the number of choices before making final evaluation and decision, and the evaluation phase, where investors focus on loss aversion rather than risk aversion. They're more concerned with the change in wealth than their level of wealth, and are more affected by a loss than a gain of the same size. And they become risk-seeking to try to avoid a loss. So that's prospect theory. We're going to talk about each of those elements. In the editing phase, there are 6 operations in the editing process. Codification is where outcomes are perceived as gains or losses rather than the final states of wealth or welfare. So we code outcomes. Combination, the probabilities associated with identical gains or losses are combined. Segregation, the riskless component of any prospect is separated from its risky component. And when comparing 2 or more prospects, cancellation is where identical outcomes between choices can be eliminated or ignored. Simplification, where the precise numbers in prospects will be rounded. And detection of dominance, where outcomes that are strictly dominated are rejected before further evaluation. To simplify the choice between alternatives, people frequently disregard components that are common to all, and instead focus on those that differ between them. This cancellation phenomenon is called the isolation effect. So people are basically taking out common factors to make the decision process easier for them. In the evaluation phase, there's a probability weighting function which allows for the fact that people tend to overreact to small probability events and to underreact to mid-sized and large probability events. The value function is based on changes, not absolute levels, and the value function is S-shaped and asymmetric. Individuals experience a greater decline in value for a given loss than a rise in value from a corresponding gain. This shows the valuation function, which passes through a reference point. It's S-shaped. As its asymmetry implies, given some variation in absolute value, there is a bigger impact of losses than of gains. People are not risk-averse, but rather they are loss-averse. Experimental evidence shows that most people reject a gamble with even chances to win and lose, unless the amount of the possible win is at least twice the amount of the possible loss. In contrast to expected utility theory, the prospect theory value functions measure gains and losses, but not absolute wealth, and it is reference dependent. Here's an example. So Kahneman and Tversky, which are the grandfathers, I suppose, of behavioral finance, asked participants these questions. So situation 1, given a 50% probability of winning $150 and a 50% probability of losing $100, is an individual likely to take this gamble? Is the individual's choice likely to change if overall wealth was lower by $100? In their experiments, they show that there are few takers of this gamble. Most evidence shows that most people reject a gamble with even chances to win and lose, unless the possible win is at least twice the size of the possible loss. Let's look at situation 2. Given the choice of losing $100 with certainty, and a gamble with a 50% probability of winning $50 and a 50% probability of losing $200, which is an individual likely to choose? Would the individual's choice change if overall wealth were higher by $100? The experiment showed that this gamble may be more attractive than the sure loss. Experimental results indicate that risk-seeking preferences are held by a large majority of respondents in choices of this kind. In both cases, the gamble compared to a certain position provides an expected net gain of $25. These situations differ only in that all values are lower by $100 in situation 2. This should be an inconsequential variation. In summary, we compared traditional finance versus behavioral finance. So traditional finance assumes unlimited perfect knowledge. Behavioral finance, with bounded rationality and prospect theory, assume capacity limitations on knowledge. Traditional finance assumes utility maximization. Behavioral finance assumes satisfice, or a level of satisfactory outcome. Traditional finance assumes fully rational decision-making. Behavioral finance assumes that there are cognitive limits on decision-making. And finally, traditional finance assumes risk aversion. Behavioral finance refers to loss aversion that is reference dependent.